Hello, friends. Welcome. Welcome to another session on Quant. I'm Orko. What we do here primarily, we take topics of Quant and for Quant specifically for CAT and non-CAT MP entrance exams in India. So in the previous sessions, we talk about simple linear equation, and we also have recorded quite a few sessions. You can check them in the I button or in the description box below. I'll put a note. So this session is primarily on special equation. Now, to give a little context more, in the last few sessions, we talk about simple linear equation. We understand the fundamentals. We did couple of practice sessions with that where we covered the foundational problem as well as few advanced level problems. In continuation to simple linear equation, there are certain problems which come under special equation, and these are very important type of problems. There are a couple of concepts needs to be understood that we will do once we go through the problem, and that's what we are planning to do with special equation. We will have two sessions. So this is the first session. So this is session one for special equation, and we will have a session two where we will solve more problems. So we will solve around 10-12 problems on special equation, and that gives you an idea on how to solve the problem. Now, what is a special equation? A special equation is basically a type of equation where you have, let's say, two variable and one equation kind of a solution, or you have two variable, three variable, two equation kind of a solution, where it's not straightforward solution that you need to do. So you need to assume, you need to play around with the conditions given in the problem and then come out with the solutions. That's what we will do. A glimpse of that you possibly have seen in the problems that we did in simple linear equation. You can check those videos in the description box. I'll drop a note. But the idea here is we will solve a certain type of problem, a certain type of equations which are not absolutely straightforward. And this type of problems are favorite, absolutely favorite for CAT and non-CAT MBA entrance exam. So there are few times where you get a straightforward equation and asking you to solve that. Hardly and rarely it will happen. There may be problems given in two, three lines, and then you have to solve the problem by forming an equation, or there will be certain conditions you need to find out on which there is no solution, multiple solution, infinite single solutions. So these are the types we have solved in the previous session. This session, we primarily focus on more variable, lesser equation kind of a scenario with certain condition. Can we get the answer? Again, reiterating the fact, if you see last few years of CAT or in my SNAP IFT paper, this type of problems are very common. Absolutely common. You get to a couple of problems easily in CAT and three up to four problems in my SNAP IFT kind of exam. So with that, let's get started. So I will explain the concepts, what needs to be done before we solve a particular problem, and I will cover all the type of problem where you need a concept and where you need a practice as well. So with that, let's get started. So let's see the first problem. So they said, how many positive integer solutions do you the following equation have? Again, you see there are two variable, 4x plus 5y is equal to 100. Now, before solving this, let's start with a simple solution. So let's say, or we can use this problem also. So what we can do here is, let's say 4x plus 5y is equal to 100. Obviously, there are a lot of solution possible, but what they said both x and y has to be positive integer. So that's an important condition that has been given to you. So you can't pick any random solution on the earth. So it has to be integer and it has to be positive number. So there is certain boundaries that is given to you. So always in special equation, there will be certain boundaries given to you. So now it says 4x plus 5y equal to 100. So whenever such problems are there, I always suggest start getting the values of x and y. So since this is a positive integer, even before that, let's say, what is the easiest value you can think of x and y which will solve the equation? The easiest value. So I can think of x as 0 and y as 20, right? So that's the easiest value. So I can think on top of my mind, or I can think of y as 0, x as 25, both are valid. Now, what you have to do typically is, so this is, and understand the technique that I am going to tell you is applicable only for integral solution. By integral solutions, I mean when the values of the variable has to be integer. So the technique that I'm going to tell you is only going to be applicable for when you are trying to find out the integral solutions. Non-integral solutions, this technique will not apply. So since we are finding the integral solutions, so x equal to 0, y equal to 20. The next solution, the next value of x, or the next integer value of x that will satisfy the equation. So I have to increase the x by the coefficient of y. So x is 0. I have to increase it by 5 because 5 is the coefficient of y. So next solution is x equal to 5. So if x equal to 5, then 4x becomes 20. Then 5y has to be 80. Then y becomes 16. So if you see 4 into 5 plus 5y is 100. This is 20 plus 5y is 100. And then from there you can get 5y is 80 and y is 16. So this is so if you see what happens to y is decreased by coefficient of x. So x is increased by the coefficient of y is decreased by coefficient of x. So the next solution, again, x will increase by coefficient of y, which is 5 plus 5 become 10. Y will decrease by the coefficient of x, that is becoming 12. So if you see 4 into 10, 40, 5 into 12, 60. 40 plus 60 is 100. Then the next one will be x becomes 15, y becomes 8. Then the next one is x becomes 20, y becomes 4. Then the next one is x becomes 25, y becomes 0. Now you can't reduce y further because then y becomes negative, right? That is not a feasible solution. So this is the set of solutions that we have, right? That's one way to find out all the integral solutions. Remember, it's not necessarily to always increase x and decrease y. It also works the other way. So if there is positive integral solutions condition was not there, and you can find out any integral solutions on earth which satisfies this equation, but integral, not fractions, then you can also, from x equal to 0, y equal to 20, you could have decreased x. So in that case, your x could have been decreased by the coefficient of y. So that means minus 5, and y should be increased by the coefficient of x. So 20 plus 4, 24. So you can see this is also a solution. Then also x can be decreased by coefficient of y. Y can be increased by the coefficient of x, 28. So you can see these are the solutions as well. So the idea here is when you increase x, since this is a sum, so what is given to you, 4x plus 5y is equal to 100. Since there is a sum in between, so for sum, if x is increasing, y has to decrease so that the sum remain constant. The same way, if the equation was 4x minus 5y equal to 100, since this is a difference, if x is increasing, y will also increase. If x decrease, y will also decrease. So, for example, if the equation was 4x minus 5y equal to 100, what we could have done is x by y. Again, start with, let's say, when x is 0, what is y? Y has to be minus 20 to get the solution. Then if I have to increase both, so then x will be increased by coefficient of y, so that means 5. Y will increase by coefficient of x, so that means minus 16. So that's where you can increase. So then x becomes 10, y becomes minus 12. So You can see that's the set of solutions. So always remember, if there are two variable one equation and you are looking for integral solutions, you can still find them by focusing on getting the simplest solution first, which we did at 0 at 20, and then increase one coefficient and decrease the other coefficient. How much to increase and how much to decrease? It's equal to the coefficient of other variable. So x will increase by the coefficient of y will decrease by coefficient of x. Similarly, if x has to decrease, x has to decrease by coefficient of y. If y has to increase, y has to increase by the coefficient of x. A very, very important fundamental understanding. Please drop a note if it's still unclear to you, or you can mail me if you need further guidance on this. So that's how we solve it. So coming back to the problem, how many positive integral solutions? Positive integral solutions, I know 0 is not a positive number. 0 is a non-positive, non-negative kind of a number. If they said non-negative integral solutions, I could have included 0. But if they say positive integral solutions, I can't include 0. So my options are, this is 1, 2, 3, 4. 4 solutions are possible. So the answers are 4. 5, 16, 10, 12, 15, 8, 24. So these are the 4 solutions that will satisfy this equation. Understand, when they say positive or negative, 0 is not included. 0, if they say non-positive, that means 0 and all the negative numbers. Non-negative, 0 and all the positive numbers. So understand what is given in the problem. Right? I hope this is clear. Let's move to the next problem. Let's see what it says. Sanjay spent 340 on buying pens and markers. The price of each pen is 8 and the price of each marker is 15. So let's say he bought X amount of pens and Y amount of marker. So that means, can I write 8X plus 15Y is 340? Now this will find the maximum number of pens Sanjay could have purchased. So I have to find out X max is how much. To find out, again, let's start with this. It's the same previous problem. Here also we will start with the simplest solution first. Now here you see, if you put y as 0, if you put y as 0, then it will become 8x is equal to 340 and x is 42.5, which is not a possible solution because number of pen cannot be in fraction. So y0 is not possible. Let's say y equal to 1. I'm just thinking, and if you can find out the answer, it's perfectly fine, but I'm just trying to get. So I have to maximize x, so I have to minimize y. So if y equal to 1, I can understand 15y becomes 15, 340 minus 15 becomes a odd number, and 8x, any number you multiply with 8 has to be an even number. So obviously y cannot be 1 as well. So why I said, because the moment you multiply y, y becomes a odd number. It's a simple even odd concept. If y is an odd number of 1, multiplying that with 15 gives you an odd number. 15 into 1, 15, 15 into 3, 45, 15 into 5, 75. So all these are odd numbers. So if there is an odd number, and so then let's say 8x plus 15 is 340, then 8x becomes any odd number. If you subtract from an even number, it will become an odd number. So this becomes 325. Now 8x, any number you multiply with 8 has to be an even number. So this side is always even, this side will be odd. So obviously cannot match. Okay. 8x cannot be an even number. So that way x cannot be an integer. So y1 is not possible. Let's say y equal to 2. Y equal to 2 makes this as 30. Let's say then 8x becomes 310. X is again not a x becomes 38 point something, which is not possible. So y equal to 2 is also not possible. Y equal to 3 is again not possible. Let's put y equal to 4. So if I put y equal to 4, what I'll get? I will get at y equal to 4, I'll get 8x plus 16 is 340, and 8x is 280, and I get x equal to 35. So 35 and 4. Y minimum value has to be 4, right? So that way you can solve the problem. So, and then obviously there are other solutions. So I have to increase by the coefficient of x. I have to increase the coefficient value of the next set of solution is either I can't decrease y any further because then y becomes negative, and y cannot become negative because the number of marker cannot be negative. So y has to be increased. So y has to increase by coefficient of x. So 4 plus 8, 12. That means x has to decrease because this is a sum. X has to decrease by coefficient of y. So this is 20. Then again, this has to increase and this has to decrease. Now x cannot decrease any further because the next decrease will be another 15-point decrease. 15-point decrease makes x negative. So these are the only three possible set of solutions that is possible of this equation, because pen and marker cannot take a negative number and cannot be a non-integer. So it has to be a positive integer only. So by the problem, they are trying to tell you x and y has to be a positive integer. And by x and y positive integer, these are the only three possible solutions that are there. You can't reduce x any further, or so then x becomes negative. So these are the only three possible solutions. Out of that, I can say maximum is 35. So your answer is 35. Right. So this is possibly the same approach, but we did a little way. We tried to find out the simplest solution, and while finding the simplest solution, we said, let's try to minimize y. What is the first minimum value of y that will give me a multiple of 8? That will give me x as a positive integer. That's what we did, and that's where we got the x. Again, any doubt, any explanation, please drop a note in the comment or mail me. We can take it. Let's get started with the next problem. So if you read this problem carefully, what it says, in an acute triangle, what it means by acute triangle, because all angles are less than 90 degree. And then there are three angles, A plus B plus C is 180 degree. Now they said 13 times measure of one angle is 29 times the measure of the other angle. So 13A is 29B. This much is given to you. What is the measure of the largest possible angle? Okay. Now, if you understand 13A equal to 29B, so these two terms has to be equal. Now 13 and 29, there is no common factor. So that means A has to be multiple of 29. At the same time, B has to be multiple of 13. Because otherwise, there is no way you can make these two terms equal, because 13 and 29, there is no common factor. So A has to take something which is multiple of 29 so that gets adjusted. B has to take certain multiple of 13 so that the coefficient of A gets adjusted. So then that's when they will become equal, and that's the only way you can try. If the A is not a multiple of 29 and B is not a multiple of 13, you will never be able to equate this 13A equal to 29B. So this is the main crux. This is the main crux of the problem. If you are able to solve this, most of the problem is easy. So then let's see what are the values of A, B, C possible. So the minimum value of A has to be 29. B has to be 13, and in that case I can see C has to be 29 plus 13, 42. So 180 minus 42 is 138. So C has to be 138. So this is one possibility, but this is not possible because of this all angles has to be less than 90. The next one, if A becomes 58, B has to become 26 because both of them has to be equal. So if A is getting multiplied by 2, B also has to get multiplied by 2. So 58 and 26 becomes, what is 58 plus 26? 84. 84 means C becomes 96, which is also not possible because it's more than this. And A becomes 87. The next multiple, this becomes 39. So 87 plus 39 is how much? 126, right? 126. So that means C becomes 180 minus 126, which is 54. C becomes 54, right? So what we can see after this, if I increase A will cross the fourth multiple of 29 is more than 90. So that is not possible. So this is the last. And here I can see A has the highest value. So 87 degree is the largest angle, right? Because that this is the only possibility where all the angles are less than 90, and A and B are both multiple of 29 and 13, and they satisfy each other. So satisfy the condition 13 are equal to 29. So this is the largest angle. But the main crux of the problem is understanding this part. If you understand this, you can solve the problem. Okay. You can drop me a note if you have a doubt on this, how we got this, because that's where I have explained. But still have doubt, feel free to drop a note or mail me. Okay. Let's see the next problem. They said if x and y are positive integers, find the number of solutions. So before I go ahead with this problem, there is a concept of number of factors. Forget this problem as of now. I'll first explain the number of factors. So let's say 12 is a number. So 12 is a number. I'll try to break 12 into into a product of prime numbers. So let's say 12, if I divide by 2, I'll get 6, by 2 I'll get 3. So 12 I can write it as 2 into 2 into 3, or I can say 2 square into 3. I can write it as 4 into 3 or 6 into 2, but that's not the right way, because I want to break 12 as a product, as a factors when we identify the prime factors. So I have to write it as prime. So when I do a factorization, I have to do it with the prime factors only. Now, if I say 12 is 2 square into 3, now including prime, non-prime, how many factors are there in 12? So that tells us, so if n is a number, and let's say x to the power a into y to the power b and z to the power c is the prime factorization of n. So let's say prime factorization of n. So what I mean by prime factorization, when you break n into its prime factors, then I can say total factors of n is equal to a plus 1. So this power, this exponents plus 1 into b plus 1 into c plus 1. So in that case, for 12, the total factors will be 2 plus 1, and 3 has a power of 1. So into 1 plus 1. So that means 3 into 2, 6. So 6 factors are there in 12. So what are the 6 factors? If I say 12, so 12 has factors like 1, 2, 3, 4, 6, 12. These are the 6 factors. So there are 6 factors. So I can write 12. I can write 12 as 1 into 12, 2 into 6, 3 into 4, 12 into 1. All these are possibilities, right? So I can write 12 in any of this. So if you see, I can write these 6 factors, and each factor, 2 numbers will be multiplied with each other to give you 12. So 12 has 6 factors. So now understand this concept very well, and then we will solve the problem. So first we understand how to find the number of total factors. To number of total factors, you have to first do a prime factorization of a number. And once you do a prime factorization of a number, then taking their exponents and adding 1 to them and multiplying, this is the formula. This is the formula for n. So this is the total formula of total factors after doing a prime factorization. So from here, what I can say is this number has this many factors, right? Uh, so this is very important to understand, identify the number of factors. Now, why I need this number of factors for this problem, I'll come to that once we solve the problem. Okay, now let's start solving the problem. I think you have seen the problem. So they said 1 by x plus 1 by y is 20. So this is 1 by x plus 1 by y is equal to 1 by 20. And they said the positive x and y are positive integers. So if I just cross multiply, it will become x plus y by xy into 20. Or I can say x plus y. Sorry, this is 1 by 20. So 20 into x plus y is equal to xy. Or we can say xy, if I bring everything on the other side, minus 20x minus 20y equal to 0. Now, in terms of middle term factors, since there is 20, 20, if I add, if I have to do a factorization to it, I'll add 400 on both the sides because 400 is 20 into 20, both the coefficients. So xy minus 20x minus 20y. Since 20 is the coefficient of x, 20 is the coefficient of y. Simple middle term breaking, if you remember, we will have a constant value of 20 into 20, which is 400. So I have to do a 400 that side also. So if I take x common, it will become y minus 20. If I take 20 common, it will still become y minus 20 is 400. One can say x minus 20 into y minus 20 is 400. Now they said x and y are both positive integers. Now understand this problem very carefully. X and y are both positive integers. If you see carefully, they said x and y are both positive integers. X and y are positive integers doesn't mean x minus 20 and y minus 20 will also be a positive integer. So there is a possibility that this is negative and then this has to be negative because the multiplication is 400, which is positive. Or there is a chance that this is positive or this is positive. Now, see this carefully. X and y both are positive integers. Now, if x is a positive integer, if x is greater than 0, x minus 20 will always be less than minus 20 or more than minus 20. By saying more than minus 20, that means x minus 20 can be, if x is 10, then 10 minus 20 becomes minus 10. And y is also 10. So y minus 20 becomes minus 10. Sorry. So then the idea is it will never be equal to 400. Why I'm trying to say, because both these values will be less than 20. So since this is not possible because x is greater than 0, so x minus 20 will be more than minus 20, but negative. So it will fall between 0 to 20, 0 to minus 20. Similarly, if y is positive, y minus 2 and y minus 20 is negative. So if you think, if I say y is positive, but y minus 20 is negative, that means y minus 20 has to be more than 0 but less than 20, sorry, the other way. So minus 20 will be less than y minus 20, but this is less than 0. So it will always fall between minus 20 and 0. So the absolute number is less than 20. Similarly, in the x's case, it will be less than 20. So if both the numbers, let's say this is minus 15 and the other one is minus 10, it will never be multiplied to 400 because both the numbers individually are less than, both the absolute numbers are less than 20. So x negative, y negative is not a feasible solution. Please try to understand why it is not a feasible solution. I'm repeating again. So x and y are greater than 0. So x minus 20, if it has to be negative, then x minus 20 has to fall between 0 and minus 20 only. And 0 and minus 20, the absolute value of the number cannot be more than 20 or 20. It has to be less than 20, absolute value of that number. If it is minus 10, the number is more than minus 20, but the absolute value of the number is 10. Similarly, for y minus 20, it will also be the absolute value of the number will be less than 20. So that means both the absolute numbers are less than 20. So you can't multiply them to get 400. Can never be. So then that's why x minus 20 and y minus 20 both negative is not possible. So both has to be a positive number. So both has to be a positive number means x minus 20 and y minus 20 is equal to 400. So this is positive. This will also be positive. So if I find out the factors of 400, I will be able to get the number of solutions, right? So how many factors are there in 400? So 400, if you do a prime factorization, I can write 400 as, let's do a prime factorization. So 200, if I do 200, then I do 2, I will get 50, then I do 2, I will get 25, do 5, I'll get 5. So 4 2s, so 2 to the power 4 into 5 square is 400's prime factorization. Now that means factor is equal to 4 plus 1 into 2 plus 1. So 5 into 3, 15 factors. So there are total 15 factors of 400. So that means both x minus 20 and y minus 20 can have 15 values. Why? Because if you see this example, let's say I say x into y is 12, right? If I say x into y is 12, or let's say I say that a into b is 12. So 12 has 6 factors, right? 12 has 6 factors. 12 has 6 factors means I can write 1 into 12, 2 into 6, 3 into 4. Similarly, I can write the 4 into 3, 6 into 2, and 12 into 1. So A can take any value between 1, 2, 3, 4, 6, 12. Similar for all these values of A, B will take another 6 set of values. So that means the total number of factors are the total number of solutions. So AB can be 112, AB can be 26, AB can be 34, AB can be 43, 62, 12, 1. So if 12 has 6 factors, that means A and B can have 6 solutions. Similarly, if 400 has 15 factors, then x minus 20 and y minus 20 will have 15 solutions. So for each of the 15 solution, you will get one value of x and one value of y. So that's when there are 15 solutions possible, right? Simple and the number of solutions of the equation. So you need the solutions of x and y. So x minus 20 can take 15 values, and for those 15 values of x minus 20, y minus 20 can take another 15 values. So x minus 20 and y minus 20 together can have 15 set of solutions. So what is meant by one set of solutions? So like I said, 1 and 12 is a solution here. Similarly, for the 15 values of x minus 20, y minus 20 will have its own 15 values. So together they will have 15 set of solutions, and for each of the set of solution you will get one value of x, one value of y, and so that way you will get 15 values of x and 15 values of y, and that's when there are 15 solutions possible. Hope this is clear. Let's move to the next problem. Okay, the kind of, again, any doubt on the previous problem, drop me a note or a mail. We will be able to help you more. Now let's see the next problem. It's a simple problem, but there is an ordered pair. Similar problem to the past, but they said it's an ordered pair and there is no positive integer has to be there. So what is meant by a ordered pair? And now if you see typically the 12 wala example, I saw 2 square into 3. There are 12, I can write it as 1 into 12. 2 into 6, 3 into 4, 4 into 3, 6 into 2, 12 into 1. With all this way, I can write 12. But if you see carefully, when it says an ordered pair, ordered, that means uh, A, B is not equal to B, A. So, that means when I'm saying an ordered pair, that means my order matters. Order matters means if you remember what we did, A into B. So I'm saying 1 into 12 is not same as 12 into 1 because A is 1 and 12, B can take 12 into 1. So these are two different solutions. That's how we did the previous problem. We took these two as a two different solution. That's when we said A and B can have 6 solutions. When it comes to unordered pair, that means we are saying A and B are same as B and A. So that means 1 and 12 and 12 and 1 are the same set of solutions. So you can't differentiate between these two. So that means in that case, you will have only 3 set of solution. 1, 12, 2, 6, 3, 4. Doesn't matter who takes what value. It's a unordered pair. So 1, 12 is same as 12, 1. So those two you cannot consider as a separate solution. So unordered pair, your solutions are less because the order does not matter. When it in ordered pair, then the same set of values can be once taken by A and in the other scenario taken by B. So with two set of values, you get two set of solutions in an ordered pair because the order matters of the set. When it comes to unordered pair, you don't focus on the order, you just take the values and those values as a solution. So 1 and 12, 1 into 12 or 1 and 12 is the same set. 1, 12 is not different from 12, 1. So those two you cannot consider as separate set, separate solutions. If these are one solution, 1, 12 and 12, 1 together is one solution. So that's when the unordered pair, when the order does not matter, it's just the values matter. Order pair, order matters as well as the values. So that's why ordered pair number of solutions are more. In the previous problem, we did the ordered pair only. When we say 12 has 6 solutions and 6 is the number of factors. When it comes to unordered pair, number of factors may not be equal to number of solutions, right? A lot of time it is just divided by 2 because you can't take the other two values. So like in this case, we can see for unordered pair, we have 3 solutions. 1, 12, 2, 6 and 3, 4. In the unordered pair. Okay, now here this problem they are talking about ordered pair. So that means I just have to find the number of factors. Same previous way, number of factors, number of solutions. Simple. So if we establish that, let's get started. 3 by x, 1 by y, 1 by 24. Again, start the same thing. 3y plus x by xy is equal to 1 by 24. If I cross multiply, 72y plus 24x is equal to xy. Or if I do xy minus 24x minus 72y, then I have to multiply 24 into 72. And then I could do it this side also. So if the first two, if I take x as common, it will become y minus 24. The next two, if I take 72 common, it will become y minus 24 equal to 24 into 72. So x minus 72 into y minus 24 equal to 24 into 72. Let me reduce this font. So now, again, what we have to understand is now they have not said these are positive integers. So x minus 72, y minus 72 can be both negative or can be both positive. First, identify how many factors are there for 24 into 72. So 24 into 72. So if I take 24 separately, it's typically 2 cube into 3. The 24 is 2 cube is 8 and 3. And 72 is 2 cube into 3 square. So 8 into 9. 2 cube into 3 square. So total I can get 2 to the power 6 into 3 cube. Or I can say there are total 6 plus 1 into 3 plus 1, total 28 factors. Now this 28 factors, understand this. This 28 factors, when both of them are positive, that is also possible. When both of them are negative, that is also possible. By that I mean, if I recall this 112, so 1 into 12 is one solution, minus 1 into minus 12 is another solution, minus 2 into minus 6 is another solution, minus 3 into minus 4 is another solution, minus 4 into minus 3 is another solution, so on. So for every positive set of values, there is a equivalent set of negative values as well. So can I say 28 factors for when both of them are positive, 28 factors when both of them are negative. So total 56 factors. 56 factors means 56 solutions. But be careful. 56 factors, it's fine. But also, this is where the crux of CAT or trickiest part of the problems come. You can understand easily 28 factors for when both of them are positive. Similarly, 28 factors when both of them are negative. Like I given you the example of 12, you will see 6 factors, 6 set of product of two numbers in positive side, 6 set of products of two numbers on the negative side. So there are 12 positive factors, sorry, 6 positive factors, 6 negative factors. Now, what you need to understand is x and y are your in your denominator. So that means x and y cannot be equal to 0. So x and y cannot be equal to 0, right? X and y cannot be equal to 0. So that means x minus 72 cannot be equal to minus 72. And similarly, y minus 24 cannot be equal to minus 24. So 24 and 72 will have a factor of minus 24 and minus 72. So this factor is not possible. So x minus 72, so this value, this taking minus 72 and this taking minus 24 will still give you 24 into 72. But this is not a feasible solution because in that case, x becomes 0, y becomes 0. So you have to subtract this one factor. So the final is 55 factor or 55 solution. So answer is 55 solution. This is a very, very good problem. 55 solution. You have to subtract this one when x and y becoming 0. Okay, let's move to the next one. Again, any doubt on the previous one, please ask. And now this is a 4 set of problems. So I'll do first one and you can try the other 3 at home. So here they said x square minus y square is equal to 385. So I can easily write x plus y into x minus y and 385 ko if I have to do a prime factorization. It's not a multiple of 3. So I'll directly start with 5. 75, 5, 15. Just a minute. No, sorry, my bad. It's a wrong calculation. 77. Okay, 7, 11. So this is 5 into 7 into 11. So total factors. So again, I am trying to find out the total factors. Total factor is, this is 1, 1, and 1. So 1 plus 1 into 1 plus 1 into 1 plus 1. So total 8 factors. So number of positive integer solutions. Positive integer solutions means there are total 8 factors, right? Now, this is, can I write y and x minus y, multiple of 2 factors. So I can write, this becomes, if I take only 5, so 5 into 77, right? Now, I can also take only 7 out and I can write 5 into 11, 55. or I can take 11 out and I can write 5 into 7, 35. So 385 can be written as product of two numbers this way also. Okay. Now, out of this, what I can see typically is if you see 5 and 7, so I can say that x and y are positive integers. So x is greater than 0, y is greater than 0. So can I write x plus y will always be more than x minus y because both are positive integer. So out of these values, x plus y can take 77. This is 5, this is 55, this is 7, this is 35, this is 11. So x plus y can never take 5, x plus y can never take 7, x plus y can never take 11, because then x plus y will be less than x minus. So these are the three positive ones. Is this all? Are you not missing anything? Just think, because scenarios missing is a very critical part. They said there are 8 factors. We have written 8 factors, means there are 4 ways you can write this as a product of two multiple, or there will be 8 ways you can write this as a product of two multiple. So if I write 5 into 7, so then there will be 1 of 77 into 5, 55 into 7, 35 into 11. It's still 6 ways. What is the other way? One way is of writing 1 into 385 and similarly 385 into 1. So that means 1 into 385 cannot be there. So 385 into 1 is there. 1 into 385 is not there because x plus y becomes less than x minus y. So these are the 4 solutions that is possible. Then, so x plus y is 77, x minus y is 5. You can solve them to find x minus y. Similarly, x plus y is 55 and x minus y is 7. You can solve them to find x and y value. X plus y is 35, x minus y is 11. You can find out x and y value. Similarly, there are 4 solutions possible for x and y. So for the first one, the answer is 4. You can try the other ones and let me know. So that's about it. We will do another session of special equation, and I'll be able to help you solve more type of problem or variations of problem. Okay. Hope this session is helpful. If it is helpful and you learn something new, please like, comment, subscribe, and share as well. So that is good for the algorithm, good for my motivation, and so that it helps me to keep creating this type of sessions, which is beneficial for you. And if you need something, if you need a one-on-one session with me, please feel free to drop a mail ID and we'll be able to take it forward from there. Okay. Have a good day. I'll see you next time. Thank you.